Okay, I'm back with more probability. Okay, now first we're going to do a brief review. Remember, the wording of either or is generally additive. So you'd add together the two probabilities, like if they said pick a blue or a red. Independent events are things like rolling a die or dice, flipping a coin, or taking something without replacement. Dependent probability is certain events in a row, like taking cards, or certain other things, like pick one then the other, like marbles that are removed but not replaced. The key here is not replacing them. The gambler's fallacy, remember we talked about that with flipping a coin 19 times and coming up one way. The other way isn't due the 20th time. It's still an independent event, so it's a 1 out of 2 chance each time, including that 20th time. P is probability, the ways it can happen. Okay? P goes from 0 to 1, which is certain. So some more probability, playing cards. What's the probability of drawing an ace or a 2 randomly from a deck of 52 playing cards? There are 4 aces, there are 4 2s, 52 cards in a deck. I'll give you a moment if you'd like to solve the problem on your own. You can pause by tapping your screen or pressing the space bar button. Okay, I'm back. So remember how I always said either or are usually additive probabilities? This is an example of that. So 4 over 52 plus 4 over 52 equals 8 over 52 because there's 4 aces and 4 2s. So 8 over 52 is equal to 4 over 26, which is equal to 2 over 13. I just keep reducing. Okay, and we could divide, or you could take out your calculator. 2 divided by 13 equals 0.15, so that's P equals 0.15, or 15%. Okay, now we're going to talk about marbles and dependent probability. Given a bag with 7 marbles, 3 are red and 4 are blue. If one marble is drawn without replacement, followed by another, what are the chances of drawing a red marble both times? Remember, this is dependent probability. Okay, I'll give you a moment to press spacebar on your personal computer or tap your mobile device to pause. Okay, I'm back. Given a bag with 7 marbles, 3 are red and 4 are blue. If one marble is drawn without replacement, followed by another, what are the chances of drawing a red marble both times? There's a 3 out of 7 chance the first time because there's 3 red, and there's a total of 7. Followed by a 2 out of 6 chance. Okay, pay careful attention here because we removed one of those red marbles. So there's only 2 red marbles left. And the total is also 1 less. So it's 2 out of 6 the second time. So you multiply 3 over 7 times 2 over 6 and we get 6 over 42. Okay, so P equals 0.1429 or 14.29%. So you see how dependent probability throws a monkey wrench in things. Makes things a little different. Now, here's an aside, a tip and trick about probability and the price of tea in China. You know how I always say, be careful of irrelevancy? Here's an example. Carefully read the question. If you must be 18 or 21 or something to be in the pool of probability and the person or element isn't in a question, the probability is 0. P equals 0 means not happening. Okay? If you must be 21 to enter a bar and IDs are being checked by a bouncer so that no fake IDs are used and whiskey sours are handed out free to every second patron, the probability Jack, who is 14, has received a whiskey sour is P equals 0. So he hasn't, because he can't get in the door. And because even if he had a fake ID, he couldn't get in, because they're checking him. So that thing they're giving to every second patron wouldn't apply to him. Be very careful about irrelevant information in probability questions. If someone is excluded from the pool of elements, from the set of elements, from the pool of probability. If it says someone has to be located in a certain city, is the set of persons who lives in Philadelphia. What is Jack, who lives in Idaho? Well, the probability is 0. So you got to be a little careful when you see things that are very irrelevant when they're talking about who's included in this pool or set of elements. Okay? So now we're going to talk about probability and counting, or factorials. Okay, so probability is used in a bunch of stuff. We've seen it's used in dice, cards, gambling. I pointed out how it's used in computers, pretty much every predictive model, ML, AI, all sorts of things. Now let's do a problem using a different kind. This is more advanced than most of the stuff on the exam, but it could show up according to the GED test objectives. So there's 3 levers. Each will be pulled. How many combinations are there? How about 4 levers? How about 5 levers and only 3 are pulled? Okay, I'll give you a moment to press spacebar on your keyboard or tap your mobile device to pause. Okay, we're back. If there's 3 levers, each will be pulled. How many combinations are there? To figure this out, we multiply 3 by 2 by 1. This is essentially what's called a factorial. The way it works is when you're figuring out things like this by counting them, you take the total number of elements, which in this case is 3, and then you take 1 less than that, and then you take 1 less than that, and you multiply them against each other, and that's your answer. You could chart this out if you'd like as well with 3 levers and put them in the on or off position, or you could use 3 coins to simulate them in the exact same manner, heads or tails. You could line up 3 coins, heads or tails, if you want to figure this out and go through it. It's the exact same thing. You could use a similar chart to what we did when we were doing coins. If that helps you, by all means, use a chart. Okay, that's what your scrap paper, that is what for the whiteboard or other scrap device that you may be provided is there for. Okay, how about 4 levers? Same thing. 4 times 3 times 2 times 1. Here's where it gets tricky. The exam usually doesn't go this in depth, but occasionally it will. It's called a factorial. Now, if you have 5 levers and only 3 are pulled, you have to use an equation. It would be n factorial divided by n minus r factorial. And what that means is if you have 5 levers and only 3 are pulled, you have 5 factorial, and remember a factorial would be 5 times 4 times 3 times 2 times 1, divided by the n, which is that factorial, minus r. And r is the number that are pulled. You could also consider the denominator being the factorial of the number left over. It's the same thing. So 5 factorial divided by 5 minus 3 factorial is equal to 5 factorial divided by 2 factorial. And you go, whoa, I don't know what the heck this is. Don't worry, we're going to go over how you do that. What you do is you start multiplying it down. So it's 5 factorial is equal to 5 times 4 times 3 times 2 factorial. Put the factorial there, stop. Okay? Divided by 2 factorial. 2 factorial is equal to 2 times 1. Now, they cancel out, both factorials, the 2 factorial and the 2 factorial. So now it's equal to 5 times 4 times 3, which is equal to 60. So if we have 5 levers and only 3 are pulled, there's 60 combinations. That's without repetition. Okay? Now, the best way to practice this is by doing problem sets. Usually on the exam, they'll have something closer to the first 2 problems. If there's 3 levers, each one's pulled, how many combinations? So you have to know, okay, 3 times 2 times 1. That's a basic factorial. 4 levers, 4 times 3 times 2 times 1. 5 levers, 5 times 4 times 3 times 2 times 1. 5 levers and only 3 are pulled. That's where the factorial and factorial division comes into play. And you might want to rewatch that portion of the video. Okay. All right, and that's it for this domain. I will be back next time with graphs. I'll see you then.